In September 2025, Harvard University became the epicenter of a scientific upheaval that would send shockwaves through the global research community. The world's attention turned to the historic campus, as whispers of an unprecedented discovery began to circulate among scientists, journalists, and the public alike. The air was thick with anticipation, and the sense that something extraordinary was about to unfold was palpable. An emergency briefing was hastily organized, drawing together some of the brightest minds in astrophysics, planetary science, and materials engineering. The reason for this urgent assembly was a discovery that defied conventional explanation: microscopic metallic spheres, recently recovered from the depths of the Pacific Ocean, that seemed to challenge everything we thought we knew about our planet and the cosmos beyond. These tiny spheres were not just ordinary debris. They were fragments of an object believed to have originated from another star system, their composition so unique that it bore no resemblance to any known material on Earth. Advanced laboratory analysis revealed atomic structures and isotopic ratios that had never before been documented, hinting at a truly alien origin. At the center of this historic moment stood Professor Avi Loeb, the renowned astrophysicist and head of Harvard's Galileo project. With unwavering conviction, he presented not just theoretical models or speculative ideas but tangible, physical evidence, samples that could be touched, measured, and scrutinized by the scientific community. His presentation was met with a mix of awe, skepticism, and excitement. The spheres, identified as remnants of meteor IM-1, represented the first confirmed interstellar object ever detected striking Earth. Their journey across the vastness of space, culminating in their fiery entry into our atmosphere, was a story written in cosmic dust and metal. For the first time, humanity held in its hands material that had traveled from another solar system. The chemical makeup of these fragments defied all known natural and man-made alloys. Their unique properties sparked intense debate among experts. Were these spheres the product of natural cosmic processes, or could they be evidence of advanced technology from an extraterrestrial civilization? The implications were staggering, and the scientific world found itself at the threshold of a new era of discovery. This extraordinary briefing at Harvard marked not just the unveiling of a remarkable find, but the beginning of a rigorous scientific investigation, one that promised to challenge our assumptions and potentially redefine our understanding of the universe and our place within it. To understand the spheres, we must look back to January 8, 2014. That day, an object, IM-1, blazed through Earth's atmosphere at 60 kilometers per second, exploding over the Pacific. Classified as Interstellar Meteor 1, its speed and hyperbolic trajectory proved it came from beyond our solar system. In 2022, U.S. Space Command confirmed IM-1's interstellar origin with near certainty. IM-1's toughness was even more remarkable. It survived pressures 4 times greater than those that destroy typical iron meteorites. This suggested a composition far stronger than ordinary space rock. Professor Loeb wondered, could IM-1 be a manufactured object, not just a meteor? This question drove him to launch a daring deep-sea recovery mission. Loeb and his Galileo project team faced a daunting task: recover IM-1's fragments from nearly 2 kilometers beneath the Pacific. The mission, funded by crypto entrepreneur Charles Hoskinson, chartered the Silver Star and assembled a world-class crew. In June 2023, they set sail for the meteor's last known coordinates. Their main tool, a custom magnetic sled designed to collect ferrous debris from the ocean floor. For weeks, the team tirelessly dragged the sled, hoping to find spherules, tiny molten droplets from the fireball's explosion. Each haul was painstakingly examined, driven by the hope of finding the first physical evidence of an interstellar visitor. The search was grueling, but the scientific stakes were unprecedented. The Silver Star's daily routine was relentless. Each morning the crew awoke before sunrise, bracing themselves for another long day of scientific exploration. The vastness of the Pacific stretched endlessly around them, a constant reminder of the challenge they faced. Every task was performed with precision and care, as the team knew that even the smallest oversight could jeopardize their mission. The magnetic sled, a specially designed instrument, was carefully lowered 1.7 kilometers to the seabed. Suspended by thick cables, it disappeared into the inky depths, vanishing from sight as it descended along IM-1's projected path. The sled's powerful magnets were engineered to attract and collect metallic particles hidden within the ocean sediment. a process that required patience and precision. After hours of slow, methodical towing across the seafloor, the sled was finally hauled back to the surface. It emerged caked in thick mud and debris, evidence of the challenging environment below. The retrieval was a tense moment, as the team anxiously awaited any sign of success. The team scraped every bit of material from the magnets, determined not to miss a single particle. Every clump of sediment was precious, representing hours of effort and the hope of discovery. The collected material was carefully transferred to the onboard laboratory for analysis. In the lab, scientists used sieves and high-powered microscopes to separate and identify sub-millimeter particles. Each sample was meticulously examined, with researchers searching for anything unusual or out of place. The process was painstaking, requiring both skill and patience. For days, the only finds were volcanic ash and terrestrial contaminants, common materials that offered no clues about IM-1. The mood on board grew tense as the team wondered if their efforts would pay off. Then, a breakthrough. Under the microscope, a perfectly spherical metallic droplet appeared, its smooth surface and unique composition setting it apart from the rest. It was a moment of triumph, the first real evidence that something extraordinary lay hidden in the sediment. Excitement surged through the lab as more spherules were discovered. Each new find was carefully documented, photographed, and cataloged, adding to the growing sense of accomplishment. In total, over 700 metallic spherules were recovered, tiny, cosmic breadcrumbs believed to be remnants of IM-1. Their discovery was a testament to the team's perseverance and the power of scientific inquiry. These precious samples were carefully sealed in labeled containers and prepared for shipment to Harvard, where further analysis would unlock the secrets of their origin and perhaps reveal new insights into our universe. Back at Harvard, analysis of the spherules revealed astonishing results. Their chemical makeup, rich in beryllium, lanthanum, and uranium, didn't match any known meteorites or human-made alloys. This unique Beleu signature pointed to an origin outside our solar system. Further tests confirmed the spherule's interstellar nature and revealed a striking absence of nickel, common in Earth's iron meteorites. Isotopic dating suggested some spherules could be nearly as old as the universe itself. These findings set the IM-1 spherules apart from any terrestrial or solar system material. The evidence was mounting. These were ancient relics from a distant alien environment. The mystery deepened. What kind of world or intelligence produced them? Faced with these anomalies, Professor Loeb proposed a bold hypothesis. The spherules might be fragments of extraterrestrial technology. Their unique composition and extreme strength suggested deliberate engineering, perhaps for interstellar travel. Loeb argued that nature rarely produces such materials, and the spherules' properties could be hallmarks of advanced design. This wasn't Loeb's first foray into such ideas. He'd previously suggested Oumuamua might be artificial. Now, with IM-1, the search shifted from distant observation to hands-on investigation. Loeb emphasized this was a hypothesis, not a conclusion, but insisted science must follow the data, wherever it leads. The Beleu spherules became the first tangible clue in the search for alien technology. Loeb's claims sparked intense debate. Many scientists cautioned that the Beleu composition, while unusual, might have natural origins we don't yet understand. Critics warned against jumping to artificial explanations, urging exhaustive exploration of natural processes. The debate revealed a philosophical divide. Should we actively search for technological signatures or demand extraordinary evidence first? For some, the spherules are a fascinating anomaly. For others, they fall short of proof. The findings are now under peer review, every detail scrutinized by experts. Whether natural or artificial, the discovery is pushing the boundaries of geochemistry and astrophysics. The search for answers is driving science into uncharted territory. The Beleu spherules have already transformed astronomy, opening a new chapter in our understanding of the universe. These tiny metallic beads recovered from the depths of the Pacific are more than just scientific curiosities. They are tangible evidence that material from beyond our solar system can be studied right here on Earth. For the first time in history, scientists are able to physically examine interstellar material in the lab, rather than relying solely on distant observations through telescopes. This hands-on approach allows for detailed chemical and structural analysis, offering clues about the origins and journey of these mysterious objects. The Galileo Project, a pioneering scientific initiative, now pursues two ambitious goals: to conduct deeper, more comprehensive analysis of the spherules already found, and to launch a new expedition in search of larger IM-1 fragments that may still lie hidden on the ocean floor. Discovering a bigger piece could be revolutionary. If such a fragment were to show unmistakable signs of technology, like intricate circuitry, deliberate engravings, or evidence of engineered structure, it would fundamentally change our understanding of what is possible in the cosmos. Such a discovery would provide the extraordinary concrete evidence that the scientific community demands before accepting the existence of extraterrestrial technology. It would spark debate, inspire new research, and potentially rewrite textbooks. But beyond the search for aliens or advanced civilizations, this quest is a testament to humanity's relentless drive to explore, to question, and to understand the unknown. It is about pushing the boundaries of what we know and daring to ask what lies beyond. The search reminds us that profound mysteries remain, not only in the vastness of space, but also in the unexplored depths of our own oceans. Each new discovery, whether cosmic or terrestrial, challenges us to look deeper and think bigger. Whether IM-1 turns out to be a strange, never-before-seen rock or a fragment of an ancient spacecraft, the pursuit itself is what advances science. Every question asked, every sample analyzed, brings us closer to understanding our place in the universe. The ongoing search challenges our assumptions, forces us to confront the limits of our knowledge, and expands our view of the cosmos. It is a journey that requires both skepticism and imagination. In curiosity and persistence, the true spirit of science endures. As long as there are questions left unanswered, the search for truth must and will continue.